Hello everyone, welcome. Yeah, so my name is Fatih. I am an Android developer at the DNB Bank in Norway. So today we're going to talk something really interesting, which is Compose Runtime. And we will also see how we can create client libraries using this Compose Runtime. Before start, I would like to actually see your hands if you have ever kind of created library using Compose Runtime or played with Compose Runtime. No? No hand? Okay. Okay, kind of, yeah. But that's cool. This is what we're going to do today, right? We're going to go to the Compose internals first because I find it really interesting to learn the internals in order to be able to create our own library. Then we will jump to the creating library part. First things first. Compose is a UI framework, right? But it's not actually true, like not 100% true, because if you look at the Compose, it is a combination of 7 different libraries. And if you go deeper and check those libraries, not each and every library is related to UI. For instance, these ones, like Compose Compiler and Runtime. They're really cool ones, but they are not really related to UI. So today we're going to be focusing on this part. We're going to see how the compiler works with Compose Runtime, and we will also see how we can use Compose Runtime. Okay, we keep telling client libraries, but you might already know, but let's just go over again. And what are the client libraries? Client libraries are basically the APIs that is meant to be used from the client side, right? So if we're going to give an example, they're kind of the middlemen, like make the APIs better for you to use in your client code. So since we're talking about Compose, I'm just going to give an example from Compose. We have different layerings of Compose, right? And here, we have the different libraries, like Material, Foundation, but everyone is using the other one, like Material is using Foundation, Foundation is using UI. So those are actually client libraries. But today, we're going to focus on this thing, the UI part. We're going to try to switch this UI with our own implementation, and we will see how we can create this UI library. So we will first start talking about Compose Compiler, even though we're not going to be directly using Compose Compiler. Like, we're not going to do any changes for Compose Compiler. Maybe we can't for the creating client libraries, but we will see how does compiler work with Compose Runtime. And we will also, of course, talk about runtime and the things like Composer, slot table, and Applier. And we will also see how we can make client integration so that the clients are able to use our own library. And at the end, we will see how we can create Compose client library for PowerPoint. It might not really make sense. I know it's just for fun purposes and learning purposes. So we will try to create one for Compose PowerPoint. Of course, we're not going to implement each and everything here, but at the end, I'll be also sharing the open source project as well. First, let's start with the Compose Compiler. Compose Compiler is a Kotlin compiler plugin. And I find it very similar how, if you have ever used suspend functions in coroutines, so I find it very similar how both works together. Both works, actually. So when the suspend function works, like Kotlin compiles the code, and then it does some magic under the hood, and same as Compose Compiler. So when the Compose Compiler is doing its job, it's transforming your composable functions to something that Compose Runtime understands. So you might be thinking that like you just write composable functions and then it just works magically. Of course, it works magically, but by the help of Compose Compiler. So what does it actually do? It does a lot of stuff. It does, for instance, injecting something called Composer, which we will see in a bit. It also does some stability checks in order to understand if your composable has changed and if recomposition is needed or not. And it also starts group, which is related with something called slot table. We will also see it in this talk. And it is powering the live literals, etc. So that was Compose Compiler, and then we're not going to go into much into details about compiler because we're not going to actually need to know more than this. But when it comes to Compose Runtime, what is Compose Runtime and what is the responsibility of Compose Runtime? Compose Runtime, you can think of it's the brain of Compose. And without Compose Runtime, there is no Compose because it's the state management and fundamental building blocks of the Compose. But how does this work actually? So we're going to see 4 things today. We're going to focus on first Composer, and then slot table and Applier, and at the end we will see something very similar to what we already know in the Weave system, Weave 3. We will also see how the Compose node 3 is being created. Let's start with Composer. Composer is, you can think it is the bridge between your composable and the slot table. So Composer is actually doing some stuff that you don't need to do. Like if we didn't have Composer, then you would need to do these kind of things, like bridging between the slot table, the Compose Runtime thingy, and your composable by your own hands. But luckily, Composer is being injected by Composer, and everything that is related to the Composer is being done by Compose compiler. What does it do actually? It can insert, update, or end groups in the slot table because it is basically giving an information about your composable to slot table. Slot table, we will also see it in a bit. It can remember values. You might be thinking that, okay, now I have just written remember, and then it just works magically out of the box, right? Of course, but the Composer is the one who is making it possible. So when you say remember, Composer says that, okay, now we have this remember function, and then what we need to do is that we need to remember this in the slot table. So Composer is the one who is fixing this for us. It can also record changes for your composable. As we said, it is keeping, or it is actually getting your information, getting an information about your composable and recording it, right? So later on, it can be actually diffed when there is a recomposition step. Like if your composable has changed or not, it can be understood and then it can be executed again. And of course, it's, as we said, it is targeted by Compose compiler and being injected by Compose compiler. Well, that might be a lot of words right now. I think it's better to just try to visualize these things. So let's start to visualize it a bit. Let's say we have a composable function called hi. And as we said, when there is a compilation happens, Compose compiler comes into play and doing its magic, like injecting the composer, starting the groups, etc. Now, after the compilation progress, you have everything ready inside your composable. What happens is that, let's say you run your application and your composable on runtime has been called for the first time. Then it interacts something called slot table. Remember what we have been telling is that Composer is the bridge between the composable and the slot table. So now it's time to talk more about the slot table. What is slot table? Slot table, you can think slot table is an in-memory database for your Compose and composables. So it is keeping the data for your composables. Like for instance, if you remember value, so it is keeping that remembered value as well as the metadata for your composable. And it also keeps the current state of the composition so that when there is another round of composition, the recomposition part can be understood, like which composables are going to be executed again and which composables are not going to be executed. So that data is actually coming from the slot table. But how? How the slot table is actually working, and how does this work? So it is working by the help of 2 things. First one is groups, and the other one is slots. Groups are the things that turns the linear cache into a tree-like data structure. For instance, you have a composable A that has been called from composable B, and that has also been called from composable C. So that means that you have a structure like, linear structure like CBA, right? And groups are the ones who are turning this into a tree-like structure so that in Compose, it can be understood like, okay, now A's parent is actually B, B's parent is actually C. And it's basically keeping the metadata for your composable, right? So whose parent is what is actually those kind of metadata is being kept inside something called groups. But where do we actually keep the actual data? For instance, if you remember integer 1. So where do we keep that actual value 1? So we're keeping that value in something called slots. Actual data goes for slots, metadata goes for groups. If you want to learn more about the slot table and how the slot table works, I highly go checking out the Leland's article, because he's the one who is working with the Compose compiler, and I think he's the one who knows most about the Compose compiler. So I highly recommend going and checking out this article. All right. So let's go back to visualization part. Now we know a bit about the Compose compiler, Composer, and slot table, right? Now we say that, okay, our composable has been called on runtime, and it interacted with slot table. Now slot table is filled with the data that is coming from the composables, right? But we haven't really shown anything to the user. It's still the composition progress. What is going to happen next now? So Composer, as I said before, Composer is actually recording the changes. Like if it's the initial composition, of course, it's also recording, or the recomposition, diffing the changes and recording those changes, right? After recording those changes, it delegates those changes, which needs to be applied to something called Applier. Applier, then. What is an Applier? Applier is the one who is responsible for applying tree-based operations. Remember what I said? We actually have something called compose node tree. So Applier is the one who knows how to inject or remove or move the nodes into that tree. So Composer is passing the changes, and Applier is simply applying it to the compose node tree. So as I said, it can insert, move, or remove, or even clear the whole tree. But if you go check out, Applier is an interface. And if you go check out again more, there is going to be a class called abstract Applier. And where is the actual implementation? You might be wondering, where is the actual Applier implementation? So that is actually going to be implemented by us. So the first thing is that now you can think or relate with creating the client libraries, is that now we need to create our own custom Applier, which I find it very, very cool, because it gives you a chance to do whatever you want in the Compose. Like, it's not coming from the Compose runtime, but you can actually, if you want to do some crazy stuff when there's an insertion of a node, if you want to remove the node, some kind of crazy stuff. So this is the place that you can do it, by implementing your own Applier and giving it to the Compose. Well, let's come back. Okay, now we know a bit about also Applier, what Applier does, applies the tree-based operations to something called compose node tree, right? But how is this compose node tree working? Or how is this compose node tree being created? Well, let's visualize another thing then. Now let's think that we have two composables called high and dev. What happens under the hood for every composable that uses that, every composable is doing something called emitting a node. Every composable, it doesn't matter which composable, like it's going to emit a node, and when it emits a node, it just sends nodes to Applier, and Applier knows about the nodes, and Applier is creating, if it's the initial composition, it's creating the tree or simply updating the tree based on the changes that has been passed from the composer. But now there's another thing. How is this compose node being emitted, or what do we mean by emitting a compose node? So emitting a compose node basically means that creating your own type of node to represent your composable, and giving it to Compose, saying that, okay, now I have created my composable for my clients, and this is the representation of my composable in terms of nodes. So you just need to give that in order Compose to create the compose node tree. In order to emit a node, or let the Compose know that what type of node that you're using, you can use two composable functions. One of them is a compose node, and the other one is a reusable compose node. Not surprisingly, reusable is the reusable one. But what we say, what we mean by reusable is that it's just avoiding the creation of the node again, but simply reusing the place that has been created for other nodes. So if you go check out the implementation of the Compose node, and don't go and check it out and compare with this one because I know this is the old version, you might see some differences, but what you're not going to find it different is that this generic type. So this generic type means that you need to create your own node type and give it to Compose node in order to emit the node. Okay, now we know that we need to create our own node type, right? So when we're going to visualize it, let's think that we just created our own node type, which is called text node. And for both of the composables, I want to emit this text node. Then what I'm doing is that I am just using the Compose node to emit this text node, and then Compose is fixing under the hood, right? You're emitting it, and then it's going to Applier, and Applier is taking your node, and depending on if it's the initial one or recomposition, it is either creating or updating the tree by the node that you gave from your composable. All right. Now we also know how the Compose node tree is being created or updated. But the last part is basically we haven't really shown anything to UI, right? So we haven't really shown anything to user. So what's going to happen next is the materialization part. So see, you now have the Compose node tree, but you haven't drawn anything to the UI. So this part is which I find it very also interesting because now Compose is a multi-platform project, right? It gives you everything until this point. Right? The runtime gives you everything until this point, and then the drawing part, you can either draw it in iOS or in Android or in web, wherever you want on JVM platforms. So you just need to represent those node of Compose node tree to some UI. That's the part. So today we're going to see how we can actually draw this node into a presentation, like PowerPoint presentation. Cool. We have talked about most of the things, but what we haven't talked about is how the composable is being called on runtime. So you might be thinking, of course, you give the composable, and then when you call the composable, it's going to be called, right? But there is one thing. If you ever use Compose in Android, there is something called set content, right? It's either coming from the activity, or if you're using Compose view, it's coming from the Compose view. But there is an entry point for your composable. Without using that set content entry point, you can't write composable, right? So you just simply write the set content, and then you place it inside, you place your composables inside the set content lambda. So that is the part that we call it actually client integration. What is client integration and how does it work? Has anyone checked what set content function is doing under the hood? No? Yep, cool. 1%. But yeah, we'll just simply explain what this client integration or set content is doing under the hood. It is getting your composable content because it needs to know what composables that you have given, right? Then what happens is that it creates a frame clock and something called Recomposer. Again, not surprisingly, Recomposer is the one who is managing the recomposition things. Like, it is just orchestrating about this recomposition, listening the state changes and letting the Compose know that I need to recompose right now. It also creates the initial composition. So you might also be wondering, like, there's this composition term going around, right? So, and this composition is being created, etc. So this client integration is the place that you create the initial composition as the parent of any other composition that might happen. Also, it observes the snapshot changes. Like, if you are using the state objects in Compose, you might also be thinking, oh, this is so cool, right? So I just need to change the state object, and then it's going to recompose for me. It's actually going to do that, but by the help of client integration. So in that client integration, if you go check out the implementation, it actually listens each and every state change, which we also call snapshot change. And whenever there's a change, it lets the other observers know that now there's a state change. Do whatever you want. Like, this is the one who has changed. Now it's time to either recompose or trigger the recomposition. So client integration is the one who is actually listening it and sending it to the ones who are listening to apply some stuff. And it is also, of course, responsible for refreshing the frame and rendering the node again and again. Cool. So we kind of know what is going on under the hood for Compose, right? So now we know that like the composer is the bridge between the composables and the slot table, and slot table is the one who is keeping the data for composable. And then it goes to Applier. Applier is the one who is creating or updating the tree. And then eventually that compose node tree is being created or updated. It's been drawn to UI. But it's time to create or see some code and create something for us, some custom library. Compose client library for PowerPoint. Actually, the fun fact is that like I was presenting something in one of the talks. I can't remember. Maybe it was in Berlin. Then I was thinking, oh, wouldn't it be so cool to just like write some composable and then just output some PowerPoint? I hope there was an API for Keynote, but like for now there's only API for PowerPoint. So this is why I had to pick PowerPoint. There is no real-world usages for this, but it's just for fun and just to learn how we can do this. So what we're going to do is that we're going to create one presentation which has one slide, and inside that slide there's going to be a text called Hello Stranger. But this is all going to be generated from the composables that you have written. Let's see how we're going to do that. In order to do that, we actually need 4 things. First of all, we need the nodes, custom nodes that we are going to use, right? In this case, we need a node called text node, and we also need a node called slide node. Of course, maybe you might want to have some presentation node or something, but for simplicity, we just need to have 2 nodes for now. Then we need a custom applier, because like this is the place that we're going to be implementing and giving an information to Compose about how to insert my custom node types or how to delete and remove or move the stuff. And the third thing is that we also, of course, obviously need a composable to expose it to the client side, right? The clients are not going to be interested in the nodes or the appliers. That's going to be handled internally. The clients are only going to see the composables and only going to call the composables. So we need 2 composables for the text node and the slide node. And also we need a good client integration, which does the things that I have just mentioned, like creating the initial composition, listening the state changes, and creating the broadcast frame clock, the frame clock, and the recomposer. Cool. Let's start with the nodes. And just to say that if you just can't follow up, I'll be sharing each and everything, and I'll be summing up everything that we have mentioned here. So don't worry. In order to create a node, we actually need abstraction, because we're going to give this abstraction to the applier, and the applier is going to be basically getting this abstraction of the node. So we need to create an abstraction for our node. In our abstraction, we have the children, like any node can keep another node type that we created called Compose PPT, and it can have a list of these nodes as its children. And it also knows how to render itself. Like it needs to render it to the actual UI, right? In our case, it's the PowerPoint slide or presentation. So it needs to know how to render itself. Now, since we have this abstraction, we can go forward with it. So the first node that we're going to create is the slide node. In slide node, basically, we're not doing anything. Slide node, you can think of a node holder for the other nodes, and it doesn't do anything except letting the children know that now it's time to render. So it's simply letting the children know that now it's time to render when the render function is being called from the slide. Cool. That was the slide, and that was short, right? So now it's the text node. Text node is a bit different because we want to keep some data, right? We want to actually keep the data that we're going to draw inside the slide. So we're going to keep the text as a string because I want to keep it and draw it later on. And when there is a rendering happening, what I am going to do is that I'm going to need to create the slideshow and render the text. So again, for simplicity, I am not going inside the details because the open source project I'm going to share, I'm using a third-party library called Apache POE. So if you're interested, you can go and check it out how you can actually draw a text with Apache POE, giving by only string. So yeah, for simplicity, we're not going into details about how we are rendering a text with Apache POE. But just let you to know that this is the part that you just draw a text into a slide. And in real world, you're not going to be creating the slideshow either here. So you might be having another node called presentation node and creating the slideshow here, but for now, we're just creating the slideshow and drawing the text the same place, since we have a single text. Cool, that was the nodes, right? So we created 2 nodes for our client library. The second thing is that we need a custom applier. Now, we're going to see how we can create it. Remember what I said, we have something called abstract applier. Abstract applier is actually providing you some useful extensions for the list, so you can use it, like you can have a move function, which is coming from abstract applier. So this is why it's maybe useful to use abstract applier. And you give a root of your tree to your applier, and it does 4 things. Like, even though you will see 5 functions, it does 4 things. It's doing insertion, depending on which strategy you want. Like, either you want to start it from top and insert it and then go down, or you start from bottom to up, like insert it from bottom to up. So you need to pick one of them. So it's just to support different strategies, but like you need to pick one of them. And then if you go to below, then you also need to provide how you're going to remove a node from a tree, which is a list here, right? And you also need to provide how you're going to move it. So they're kind of simple. So remove and move is actually coming from the abstract applier, so you don't need to do anything, you just need to call it. And you also need to know how you can clear the tree, compose node tree. So that was an applier as well. Now we created the applier. Nodes are there, applier is there. What is next? The next one is creating the composables. So creating a composable might seem like an easy job, but since we are going to create a composable, which is a bit different, because now we need to actually emit the node that we just created with a composable function called either compose node or reusable compose node. So let's start by creating the slide composable. Oops. Slide composable is simply getting a composable lambda. It doesn't get anything for now. It just gets the composable lambda. But inside slide node, now we need to emit the node that we just created, right, for slide node, called slide node. And we also need to give the applier that we created. And then the compose knows that, oh, now I'm actually, for this slide composable, it's mapping to that slide node. It knows about what type of node it's emitting and what type of applier that it needs to use to update the compose node tree. So everything is kind of dynamic. You can even switch the applier here and give a different applier for different kind of usages. And then for the factory function, give the slide node. For the update part, there's something called update. Update is the part that is going to be called when your composable, this composable is being called again. So if you want to change something, change some data inside your slide node, or for the composable, that this is the part that you're going to do. But for now, we're not doing anything because we're not keeping any data for a slide, right? And for the text composable, it's a bit different. Now we're keeping some data for text composable inside the text node. So what we're doing is that now we're getting a text from the client, and we're doing the same thing. We're saying, okay, now I want to emit the text node that I created with, and I want to use the compose PPT applier that I created right now, just before. And for the factory, it's just the text node. But for the update part, Now, when my text composable is being called again, well, I want to also update the text inside my node. So this text, this.text is actually the text that we created inside the text node. So I want to update with the new text, right? If the composable is being called again, so that means that something has changed, which is basically the text, because we only have a text. So that means that I need to update the text value inside my text node in order to be able to keep the latest data. Okay, so that was the composable. Not the regular composables that you see every day, but like it's the composables that we need to create, we need to have for our clients. Cool. And the last part is the client integration part. Client integration part is actually longer than what we actually explained here for Applier or the nodes, because it does a lot of stuff. It orchestrates a lot of things. So now, in order to make the client integration or create an entry point for our clients, we just create one entry point called run compose ppt, and it gets a composable lambda. And under the hood, what does it do is that it just creates the frame clock. Luckily, this broadcast frame clock is implemented in Compose Runtime. You just need to create it. And it also creates something called Recomposer, is the one who is responsible for the recomposition stuff. And it also creates the root of your Compose node tree. You have to give this root node to the composition, right? So it also creates this root node, not composition, sorry, Applier. And also, you're creating the initial composition and setting the content that you get from your clients to that composition, saying that, okay, now the content of my composition is the one that I got from the client. And it does actually more stuff, like, as I said, it is listening the state object changes. It is also running the recomposer, because there is something called run and apply changes or something for recomposer. So you need to also make recomposer awake for listening the changes, and it does a bunch of stuff more. And at the end, what is important is that you need to also render the nodes. Like starting from the root node, which is the slide node, you need to start rendering, trigger the rendering, so that every node that is inside the root node is going to be drawn. Cool. That was the client integration as well. Now, we have actually created this, but how are we going to use it from the client side? It's easy. So first, you need to create a Kotlin project and call our entry function called run compose ppt and place everything inside. This is the same thing, as I said, a similar thing that we have as a set, like a set content function in Android. Now we have our own entry point called run compose ppt. And inside that, you just need to call the composables that we created. Slide composable, and give the text composable inside the slide composable lambda, and give the text. If you do that and run the application, you will see that it will output one presentation which has this little shiny hello stranger text in it. If you want to check more about this, there's an open source project called Compose PPT, and it's just for fun purposes. If you want to contribute it, you're more than welcome to contribute or create an issue. So go check out, find some problems, find some issues, and create it, and we will fix it. Cool. To wrap it up, I know there was a lot of information and there was a lot of Compose internals in it. So let's try to sum it up in 2 slides. Compose compiler is the one who is transforming your composable functions and doing the magic under the hood, like injecting the composer, making the stability checks, etc. And then, since it's injecting composer, composer is the one who is making the bridge between the slot table and your composable, like recording the changes for your composable and making it possible to save the data about your composable inside the slot table. Then, slot table is the one who is keeping the data about your composables. Like, it's an in-memory database. Think of like an in-memory database, and keeping the data, metadata, and the actual data in a separate place in the slot table, and keeps the current state. Therefore, it keeps the current state. Applier then it sends, if there's any change, it sends those changes to something called Applier. And Applier is the one who is responsible for the tree-based operations for the emitted node. And if you want to create a client library, then you actually need 4 things, even though there's going to be 3 bullets here. So you need to create compose nodes, and you also need to create composables for the compose nodes that you created. We needed to create 2 nodes, slide node and text node, and we also needed to create the composables to represent those nodes, right? So slide composable and text composable. We also need a custom applier. Every time you're going to create a new library, you're going to need to create a custom applier. And you also need a client integration, an entry point to expose it to clients, and it is the one who is orchestrating everything, like creating the composition and doing all the stuff under the hood. So that was it for today. Thanks a lot for listening to me. I think we still have 4 minutes for questions. And that being said, you can find each and every link and even more, some useful links from here. And if anyone has any questions, we can go for questions.